Stop. All right. Let me check something. Okay. All right, let me check Zoom one more time. I think it's everyone. Okay. All right, scholars. So let's see. So welcome. We are at the end of week 14, right? So a brief synopsis of the schedule of events for the remainder of the semester. Today, we're going to go through as many homework questions regarding section 6.4, systems of equations in two variables as we can. So we'll go through as many of those homework questions. And then next week, we only meet on Monday, right? So that's like the 21st. After this week, we're only going to have 3 meetings remaining. So this upcoming Monday is one of the 3. We'll use that session to go through to review exam 1. That Wednesday, the school is going to be closing at noon, so we're not going to meet that day. That's the Wednesday before Thanksgiving. So enjoy your Thanksgiving break. I would encourage you to maximize your time with your loved ones. You want to try to, do stuff like that. And then after the break, then we only meet 2 more times. We meet on the 28th of November, where we're going to review exam 2. And then we meet on the 30th of November, which is that Wednesday, which is 2 weeks from today. We'll review exam 3, and that'll be the last day of class. So then the December 1st and 2nd is the reading period. So you shouldn't really be meeting in any of your classes. Your final exam should become available on that Sunday, December 4th, and is due that Friday, December 9th at 11:59 p.m. I think it'll become available that Sunday, December 4th at 11:11 a.m. So remember that Friday, December 9th at 11:59 p.m. is the hard deadline for all assignments. So not only is your final exam due, but all assignments from Pearson are due. So the goal or the idea is that when you submit your final exam, that should be it, all right? And so what that means that for right now, you want to get all of your assignments on Pearson, get them in order. If you're going back and doing old assignments to improve your overall score, my recommendation is to prioritize your old exams, where they're going to count for nearly 80% of your overall grade. And the last thing you want to prioritize is the old homework, where that's going to be a lot of work for little to no points. And then also during the week of finals, more than likely, I'll log on during our class time just to make myself available. I'm not taking attendance or anything. You're not required to attend those sessions. I'm just going to be there. If you have questions, if you just need to reach out to me so you know how to find me. Also, hopefully you have been collaborating with Dr. Lamar for the lab component, right? You can see your lab grade on Blackboard, right? It's live. I think she's over that. So if you have any questions about the lab, you got to reach out to Dr. Lamar. Okay. Let me check on you guys on Zoom one more time. I was trying to wait for everybody. Look at this student. I think he's the last one, right? No, we still have another one. So that's fine. Okay. Yeah, we're still missing one guy, but that's fine. Okay, so let's take some time and go through as many of the homework questions together as we can, okay? Now, okay, I guess it's working. It looks like it's working. So it says, which of the ordered pairs is a solution of the given system? All right. So I'm just going to guess and check for right now. When x is 4 and y is 7, so -4 plus 7 is not 0, so it's not A. -3 plus 3 is 0. -12 plus 3 is indeed -9. So I'm just going to go with B and submit that. Okay. So then with this one, it says, determine which of the ordered pairs are solutions of the following system of equations. So instead of guessing and checking all of those, I'm just going to solve the system. Just going to solve the system. So I'm going to start by getting a copy of the original. Okay. Then I'm going to hit copy and delete. We're going to drop that copy right here. Allow paste. It's good about there. All right. So I'm just going to solve the system. I think I'm going to use. This looks kind of nasty. I guess I'll use the elimination method. And I'm going to eliminate y. Okay, so let's start by getting a copy of the original. We have this 5x minus 3y equals 7. We have -11x plus 5y equals 12. So if I'm going to eliminate y, I want the coefficients of y to have the same coefficient with opposite signs. So I'm going to multiply equation 1 by 5. And I'm going to multiply equation 2 by 3. Okay. So then when we do this, equation 1 becomes 25x minus 15y equals 35. And the equation 2 becomes -33x plus 15y equals 36. So then when we add these two equations together, a number plus its opposite adds to 0. What is that? 5 and 3, which is 8. So that's a -8x equals 60 plus 11 is 71. 60, yeah, 71. Okay. Come on. So then x equals a -71 by 8. Okay. So if this is what we get for x, all right, so I think I'm gonna plug it into equation 1. So then 5 times -71 by 8 minus 3y equals 7. Okay. Let's see. Numbers get kind of bad, but that's okay. We just have to keep moving with it. We have to go with it. 355. Okay. So on top, we'll have -355 by 8 minus 3y equals 7. I'm just going to kind of work in this space. So then we'll get 3y equals -355 by 8 minus 7. And there's an x. No, it's not x. Okay. Multiply both sides by a third or divide both sides by 3. I'm going to use my calculator. 8 times 3 is 24 minus 7 by 3. Okay. Hey Siri, what's -355 divided by 24 minus 7 divided by 3?
-355 divided by 24 minus 7 divided by 3 is approximately -17.125.
So I'm gonna go with this. So then we got negative 71 by 8 and negative 17.125. So we got, you know, something like this. But the thing is, I don't think that this was in the list of options that they gave us, right? So if we go back and look at the options, I'm not, you know, we didn't confirm whether this was correct or not, but right now we're just going to assume that it's correct. And notice that the order pair is nowhere in this list. So we would say none of the order pairs are solutions. Okay. Solve the system by graphing, okay? So if I click on the graphing tool, if we look at the two equations, the highest variable on any exponent is a 1. So that means that both of these equations are lines. So what I'm going to do is just plot two lines, okay? And then I'm going to drag them to the right position. So from the first equation, if we solve for y, we get y equals x plus 4. So that plus 4 tells us the y-intercept is 4. X plus 4, so the slope is 1. So then the second point is going to be 1, 5. Okay. And then for the second equation, if we solve for y, the y-intercept is 14. Okay. And the slope is negative 1. So that means we should be at 113 is the second point. Okay. Notice that these two cross at 5, 9. Okay, I'm gonna check this. So we got 5, 9. Notice that 5 minus 9 is negative 4. 5 plus 9 is 14. So it works in both equations. So we got 5, 9. Okay. So they asked us to graph here as well. And I think we're still dealing with lines. So I'm just going to make 2 random lines and drag them to the right point. Actually, can't cancel. Well, I guess I got to graph it anyway. But notice that when you solve for y in equation 1, you get the exact same in equation 2. So the second equation is a multiple of the first, so it's really just the one equation. So the y-intercept is 12. The slope is negative 4. So then we should be down to 8. So we should be at 1, 8. I'm just going to hit save and check the answer. Okay. So because one equation is a multiple of the other, there are infinitely many solutions, and they're going to take on the form x, negative 4x plus 12. Okay. Okay. So in order for this system, here we're asked to determine whether the following system is consistent or inconsistent. If the system is consistent, determine whether the equations are dependent or independent. In order for the system to be inconsistent, these lines will have to be parallel, which means they have the same slope. These lines are not parallel. And then in order for them to be dependent, one equation will have to be a multiple of the other. One equation is not a multiple of the other, so they're not parallel, and one is not a multiple of the other. So that means this system is consistent and the equations are independent. Okay. Now notice here, if we say what, equation 1 times 3, we get our 9x, we get our 12y, we get our 15. So equation 2 is a multiple of equation 1. So the system is consistent and the equations are dependent. This one, if we multiply equation 1 by 2, we'll get 8x, we'll get our negative 10y, but we don't get 18. So when we go to solve the system, all of our variables are going to cancel and we will be left with a false statement. So that means that we're working with lines that are parallel with different y-intercepts, so the system is inconsistent. Okay. Let's see. Okay, I was going to see maybe, let me see. Yeah, okay. So maybe we should take some notes here. So let me get a screenshot. Okay. And let me copy and delete. I'm going to paste the copy here. Allow the paste. That's good about there. Okay. So they're asking us to solve using a substitution method. Okay. So fortunately, they already solved for y in equation 2, so we can take that and plug it into equation 1. So then we'll get 2x, 2x minus 4, and our y is 4x plus 24 equals 16. So we have one equation, one unknown we can solve. We can distribute this -4. We get 2x minus 16x. 80 plus 16 is 96. So minus 96 equals 16. 112. If we add 96 to both sides, 90 plus 10 is 100 plus 12, 112, right? And 16 minus 2 is what, -14? Nine, 90 plus 36, 8, 80 plus 32. I think it's 8, right? -8. 80 plus 32, yeah, 112, okay? So we got this for x. So then we can plug it back in. So for y, it's going to be 4 times -8 plus 24. -32 plus 24. 6 and 2 is -8. So it looks like we get -8, -8 as the order, as the solution. Okay. Now we could check, if you plug it in. I'm just going to submit it in Pearson just for the sake of time, though. So we got one solution, -8, -8. Parentheses, -8, -8. Okay, so we're asked to solve with the substitution method. Okay. Copy and delete. Okay. So they're asking us to solve using the substitution method. So if we solve from y from equation 1, we get y equals x minus 2. If we take this and plug it into equation 2, we get 8x plus 9 times x minus 2 equals a -137. Okay, so same kind of deal, just different numbers. 8x plus 9x minus 18 equals a -137. 17x equals negative. If there were 20, that would be 80 plus 37. Oh, 107, so 117 plus 2 more, so 119. Hey Siri, what's 119 divided by 17?
119 divided by 17 is 7.
Okay. So then that means that our y is going to be equal to negative 7 minus 2. So then y equals negative 9. So then our claim is that negative, why do I keep doing that? Negative 7 by negative 9, is our order pair, is the solution to the system. Okay. Negative 7, negative 9. This one. Parentheses. Negative 7, comma, negative 9. Okay. Substitution. Okay. The same kind of deal. Wait a minute. Notice if we multiply equation 1 by 2, we'll get 8x, we'll get our negative 2y, and we don't get 14. So what that means, when we go to solve, all our variables are going to cancel, but we finish with a false statement, so the solution set is going to be the empty set. It's no solution. We're working with parallel lines with different y-intercepts. Substitution, okay. Okay, copy and delete. Let's go about there. All right, so this is an example of solving a system of nonlinear equations, right? So the recommendation is to solve using substitution. So it looks like it's easier to solve for y, thank you. To solve for y from equation 1. So then we'll get y equals, I'm gonna write it as 1 minus x. So then we can take this and plug it into equation 2, and we'll get x squared plus x times 1 minus x minus 1 minus x squared equals negative 1. Okay, let's expand. I can distribute this x here. We get x squared plus x minus x squared. And then we can expand that trinomial. We're going to have 1 minus 2x plus x squared equals negative 1. We need to distribute this negative. Okay. And a number plus its opposite. A number plus its opposite as 0. So then we're left with, we have x minus 1 plus 2x minus x squared equals -1. I'm going to move everything to the right-hand side. Okay, so if I add x squared, we'll get a positive x squared minus 3x. If I add 1, we're at 0. Okay, so then this equals 0. Okay. So then if we factor, we'll get x times x minus 3 equals 0. So then we'll get a couple of solutions. We'll get x equals 0, and we get x equals 3. Okay. We need to find the corresponding y. So when x is 0, y is 1. When x is 3, y is -2. So then I claim that the solutions to the system are 0, 1 and 3, -2. Okay. Now, if this were a testing environment, I would check by plugging each of these ordered pair into the system. They both should work in all equations, okay? 0, 1, 3, -2. 0, 1, 3, -2. Okay, I'm just gonna go with it. Let me see the time. We got a solid 10 minutes. Let's try to take advantage of this 10 minutes. Solve by the substitution method. Okay, so notice that equation 1, if we multiply equation 1 by -3, we get our -3x, we get our positive 12y, and we get our -15. So that means equation 2 is a multiple of equation 1. So that means that there are infinitely many solutions that take on the form. Now we need to solve for y. So if I add and subtract, we get what? We get 1 over 4x. So 1, nope, that's not a 1. 1 over 4 times x minus 5 over 4. Okay. So when there are infinitely many solutions, all solutions are going to take on the form x, comma, whatever your y is. So you have to solve for y from your system, right? Okay. Solve by the elimination method. Let's take some notes here. Okay, I'm gonna hit done, copy and delete. Okay. All right, so we can use elimination. I think I'm going to use the linearizing substitution. It's basically a substitution method. I usually call it U substitution, right? So I would say let u equal x squared, and let v equal y squared, right? So then if we make those changes, we're going to have 3u minus 2v equals 9. Then we're going to have 4u plus 3v equals 63. So now we want to choose a variable to cancel. I feel like canceling out the v might be a little bit easier. So if I'm going to cancel v, I want to multiply equation 1 by 3, each term by 3, and equation 2, each term times 2. Okay. So then when we do this, 3 times 3 is 9u minus 6v equals 27. Okay. 8u plus 6v equals, what is that, 126? So then when we add these two equations together, a number plus its opposite adds to 0. Okay. 17u equals, that's 140 plus 13 is 153. Hey Siri, what's 153 divided by 17? 6?
153 divided by 17 is 9.
9. Same thing happened earlier. 9, right? So then if u is 9, I'm going to plug this into equation 1. So then 3 times 9 minus 2 times v equals 9. Okay. So what is that, 27? If we subtract 27 from both sides, we get negative 18. So then v equals 9. Okay. So then we need to go back and plug in. So we say u was x squared, so that means x squared equals 9. So when you take the square root, x equals plus or minus 3. Okay. And then we said y squared equals v. That also is 9. So then that means that y equals, when we take square root, you have to introduce plus or minus. Okay, like this. So then basically it's all 4 combinations using those two. I'm just going to highlight them like this and type the correct answer. Okay. And here, we want to do all combinations with the plus or minus 3. So for instance, we're going to have minus 3, comma, minus 3, comma, parentheses, minus 3, comma, positive 3, comma, 3, comma, minus 3. And the last one is 3, comma, 3. Now notice I didn't check it. I should check it, but I'm just going to submit it for Pearson and let Pearson check it, just for the sake of time. Okay. Elimination method. Now notice if we multiply the first equation by negative 5, we'll get our negative 5x, we'll get our positive 5y, but we don't get negative 35. So when we go to solve, our variables are going to cancel and we're going to finish with the false statement. That means that the solution set is the empty set. Okay. So this is a random thing that I came across. You know, I want to call myself a conspiracy theorist. I mean, but it's just like so many of them are proven to be true. It's just like maybe there is a conspiracy, right? But I'm bringing this up because I was watching some conspiracy videos the other day, and one of them was about, what did it say? The claim was, if you ever have hiccups, you remind yourself that I'm not a fish, and supposedly it works. And I ain't gonna lie, I've gotten hiccups maybe on 3 different occasions. Every time I get the first hiccup, I say to myself, I am not a fish, and then I don't get hiccups anymore. I have no idea how and why that works, but it seems like it's working. It happened just now. I got a hiccup. I said to myself, I am not a fish, and for some reason it stopped. It's the most random, bizarre thing, right? It's so random. Okay, solve by elimination method, right? Okay. So notice if we multiply equation 1 by 2, we'll get our 8x, we get our 10y, and we get 4. So that means equation 2 is a multiple of equation 1. So that means we have infinitely many solutions, and the solutions take on the form of, now we got to solve for y. Okay, subtract and divide. So we'll get a negative 4 by 5x. Okay, subtract plus 2 over 5, plus 2 by 5, okay? So because equation 2 was a multiple of equation 1, that means we have infinitely many solutions, and all solutions take on the form x, comma, y. We had to solve for y to get all of this. Right? When you solve for y, you get this. Let's do a couple more. Use any method to solve the system. Okay. So one equation is not a multiple of the other. Okay, if we add these together, we'll get 8x equals, what is that, 32? So then x equals 4, right? So then when x is 4, what's the corresponding y? I'm going to use equation 1. Looks like it's 0, right? I'm going to go 0. Okay. Looks like 4 comma 0 works. Let me check on you guys as well. Okay, he appeared. Okay. Let me log that. Okay. I can shut this down because everybody made an appearance. Okay. I'll close this out. Done with that. Okay. Use any method to solve the system. One equation is not a multiple of the other. Okay, so let's take some notes. I think elimination might be easiest here. Let me get a copy. Okay. Hit done, copy and delete. We'll make this the last one. Paste the image, allow. Okay. All right, it says use any method to solve. I think I'm leaning more towards elimination. That looks like it'll be easier to do here. Let's start by getting a copy of the original. So we got this 4x, come on. We got 4x minus 3y equals 2. We got 3x minus 7y equals -8, okay? To me, it looks like the x's are easier to cancel, so I'm gonna focus on the x's. The goal is to get them to have the same coefficients with opposite signs. So I'm gonna multiply equation 1 times 3 and distribute. I'm gonna multiply equation 2 times -4 and distribute. Okay. So on top, we're gonna get 12x minus 9y equals 6. On bottom, we're gonna get -12x plus 28y equals 32. Okay. So now when we add these two equations together, a number plus its opposite adds to 0. That's what, 18? If there were 10, yeah, 18 plus 1 is 19. Okay. So that's 19y equals 38. 2. So then y equals 2. Okay. So I'm going to plug this into equation 1 just because it looks easier to work with. So then we get 4x minus 3 times 2 equals 2. So then we get 4x equals, if you add 6 on both sides, you get 8. X equals 2. So then it looks like the order pair 2, 2 should work. The solution to the system is 2, 2. Okay, let me see. 8 minus 6 is 2. 6 minus 14 is -8. Okay. So we got the order pair 2, 2. Let's see if this works and we'll call it a day. One solution, parentheses, 2, 2, enter. Awesome sauce. Okay. So we're going to go ahead and stop there. Did you guys have any questions for me? Did you want to ask any questions? So while you think about that, I'm going to go ahead and make a copy of anything that you saw me writing. I'm going to make it available for you. So I'm going to send it to Box and it'll go there. When this bar finishes loading, you'll receive a copy of anything that you saw me writing. And if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your weekend, guys. Take care. Peace.